All right, in this video I want to talk about some theorems involving proportionality. My goal isn't to rigorously prove these theorems, but rather to put them in front of you to get you to think about them and think about why they're true. And I'll kind of give you some hints along the way. So let's talk about the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So let's go ahead and get a triangle out here. Something like that. That's going to be pretty good, I think. Okay, so we've got our triangle. Let's name it A, B, C, a classic. And we need a line parallel to one side of the triangle. So we could use any line. I'm going to use this line right here. And it can go through the triangle anywhere. So I don't know, maybe like down here. I probably need a little more room than that. I don't want it to look like it's going through the midpoint. Oops. I don't want it to look like it's going through the midpoints because it's not. It could be going through any point. And so let's name these points, I don't know, E and F. What happened to D? I don't know. Okay, E and F. Now, what does this tell us? We know that it divides those sides proportionally. So AE over EB, or maybe BE. AE over BE is equal to CF over BF. Okay, AE over BE is equal to CF over BF. Now, Mr. Dussault, how do you know that? How can you possibly know that? Well, let's think about something. What if I look at this greater triangle here and get in proof mode? If I look at this bigger triangle, I know I actually have some similar triangles here, right? Even just right here. You can see that I've got corresponding angles that are congruent of two triangles, ABC and BEF. So, triangle, let's go ahead and write this. Triangle BEF is similar to triangle BAC. Mr. Dussault, why does that matter? Well, it matters because now I can say that BA over BE is equal to BF over BC. Okay, Mr. Dussault, why does that matter? Well, okay, hold on. BA is equal to BE plus EA. So BE plus EA over BE. Right? And, ooh, I'm going to write that a different way. Oops, we went too far. Okay. What if instead I wrote it like this: EA plus BE. Oops, one too many lines. Over BE equals, okay, and then BF. Sorry, this should be BC over BF. Sure, you caught that. Sorry that I'm slow on the uptake. BA over BE, the big over the small is the big over the small. My apologies. Okay, so BC looks like this. FC plus BF over BF. Now, does this look like anything to you? think back to our properties of proportions. This right here should make you think of the addition property, right? Let's maybe just write it out a little bit. EA plus BE over BE. That equals EA over BE. And I should be using AE here. That's fine. Okay. EA over BE plus BE over BE. Right? Okay, and so then I could do the same thing to this side. And it yields at the end, and let's, sure, EA over BE. Oh, man. Well, okay, so I'm just going to write it out. Gosh, dang it. Okay, so then this is FC. You know, the reason I'm frustrated is because I said I don't want to get into proving all these proofs. I just want to talk about them. I can't help myself. Okay, FC over BF plus BF over BF. Okay, so I'll leave it to you. Maybe you can find the missing step to figure out how I got from this and this being equal to EA over BE equals FC over BF. And that's this, right? I just flipped the letters around. Okay, so the bottom line is the proof is if AC is parallel to EF, then this happens, right? That's the proof. It's a great proof. Or this is a theorem, sorry. But it is the proof to the theorem is great, but that's the theorem. If AC is parallel to EF, then those sides are proportional. Okay. Let's go to the next one. If three parallel lines intersect two transversals, we can kind of do this. Then they divide the transversals proportionally. Okay, this is a similar proof to something that we had before. It's kind of hard to draw these, but these lines are just parallel, right? I don't know anything about them. Other than the fact that they're parallel. So there's 1, 2. Hopefully I don't run out of room. 3. I'm gonna run out of room. Okay, if three parallel lines intersect two transversals, so here's a transversal, there's a transversal, they divide those transversals proportionally. So I'll use letters this time. I'm gonna call this segment A. Get a different color. Okay, I'm gonna call this segment A, this one B, this one C, this one D. This can be line, I don't know, K, L, and M. So if K is parallel to L is parallel to M, and those are supposed to be cursive, but you know, you get it. Then A over B equals C over D, right? Those are divided proportionally. And remember how we talked about if these segments are congruent and then these segments are congruent, it's the same idea. Okay, so I'm not going to go through and prove this one the way I did the last one, but well, think about it. Think about why that's true. Okay, last one. The triangle angle bisector theorem, and I'm really going to have to resist proving this one. If a ray bisects an angle of a triangle, okay? Again, it doesn't have to be a right triangle. I kind of use right triangles because I feel like it makes them look a little bit weirder. If a ray bisects the angle of a triangle, so something like this. That looks like it bisects it. It divides the opposite side into segments proportional to the other two sides. So I know that this angle is congruent to this angle. I don't even like those lines. Okay, that angle is congruent to this angle. Great. And again, I'll use some letters because it makes things easier. I'm just talking about segment lengths here. Okay, length A, length B, length C, length D. A over C equals B over D. Or you could say A over B equals C over D, right? These have congruent, or they have the same cross product, so I can say that. There's a great proof to this, and I'm not going to do it. I would encourage you, if you want a proof for this, look it up. There's some great proofs online. There's great resources online. Maybe I'll even make a video one of these days to do that. So those are some proportionality theorems for you. I hope that it was informative, if nothing else.